Hello everyone, my name is Hillary and welcome back to the channel. Today, we're taking you inside one of the most critical emergencies that can happen offshore, a total power blackout. You'll see how the crew responds, how emergency systems protect everyone on board, and why preparation is the most important safety tool offshore. Let's get started.
Imagine you're working 180 kilometers offshore. Everything is operating normally. Then suddenly, every light goes out. The drilling equipment stops, the cranes freeze, the control room loses its main power. For a brief moment, the entire platform falls silent. This isn't just a power outage, this is a total offshore blackout. The platform suddenly goes dark. Within seconds, normal operations come to a complete stop. The familiar sound of pumps, compressors, and rotating machinery disappears. Only the sound of waves striking the steel legs of the platform remains. Emergency lighting immediately activates throughout the installation. Control room operators switch to emergency procedures. Maintenance crews stop what they are doing. Radio communication becomes the only reliable way to coordinate the response. Hundreds of offshore workers know that a total blackout is one of the most serious operational emergencies that can occur. Without electrical power, production cannot continue. Many support systems become unavailable. The entire installation must now rely on carefully designed emergency systems, while engineers work to understand exactly what caused the blackout. Just 1 hour earlier, the platform was operating exactly as it should. Production was running smoothly. Control room operators monitored hundreds of live process readings. Mechanical technicians carried out routine inspections on rotating equipment. Electricians completed scheduled maintenance checks. Crane operators continued lifting supplies from the standby vessel below. To anyone looking at the platform, it was simply another successful day offshore. Hidden behind the scenes, however, one of the most important systems on board was working continuously: the power generation system. Unlike cities on land that receive electricity from a national grid, offshore platforms must generate every kilowatt of electricity they consume. Everything depends on it. The living quarters, the drilling equipment, the process plant, navigation lights, communication systems, fire pumps, control systems, even the coffee machines in the galley rely on electricity generated on board. Without power, nothing works. Most offshore installations produce electricity using gas turbines or large diesel generators. These generators operate around the clock, supplying electrical power through massive switchboards that distribute electricity across every section of the platform. Normally, more than one generator operates at the same time. This provides redundancy. If one generator develops a problem, another can immediately share the electrical load. Engineers constantly monitor voltage, frequency, engine temperature, oil pressure, fuel supply, and electrical load. Every reading is carefully watched because even a small abnormality can quickly become a much larger problem. On this particular day, everything appeared normal. Then, without warning, one of the main generators detected an abnormal electrical fault. Within milliseconds, its protection system activated automatically. To someone standing on deck, it may have looked like the generator simply stopped, but in reality, the protection system had made a life-saving decision. Modern electrical protection systems are designed to disconnect equipment before severe damage occurs. They don't wait for an explosion. They don't wait for a fire. They react instantly to protect both people and equipment. Unfortunately, disconnecting one generator can sometimes place a sudden load on the remaining generators. If that load becomes too great, they may also trip offline to protect themselves within only a few seconds. The platform experienced what every offshore engineer hopes never happens: a complete loss of main electrical power. Across the installation, lights went out. Large motors coasted to a stop. Compressors shut down. Ventilation fans slowed until they became completely silent. Production ceased almost instantly. For a brief moment, the platform became eerily quiet. Then, the emergency systems began to respond. Battery-backed uninterruptible power supply units known as UPS systems immediately supplied electricity to critical control equipment. Emergency lighting illuminated escape routes throughout the platform. Automatic control systems initiated emergency shutdown procedures. And somewhere deep within the platform, the emergency diesel generator prepared to start. Because offshore, every second without electrical power increases the importance of having reliable backup systems. The next few moments would determine whether this incident remained a controlled emergency or developed into something far more serious. For several long seconds, the platform remains without its main source of electrical power. Emergency lighting casts a dim glow across the steel walkways, illuminating escape routes and emergency exits. The once vibrant offshore installation now feels strangely quiet. The familiar roar of gas turbines has disappeared. Large compressors have stopped. Cooling fans no longer turn. Production has come to a complete halt. But beneath the silence, an entire emergency response is already underway. Inside the control room, operators immediately switch from production mode to emergency operations. Years of training take over. There is no panic, only discipline. Every operator knows their responsibility. Every action follows a carefully developed emergency procedure. The first priority is protecting lives. The second is protecting the installation. Only after those objectives have been achieved does anyone begin thinking about restoring production. Control room operators begin reviewing alarm after alarm. Generator trip confirmed. Main switchboard isolated. Emergency lighting active. UPS systems supplying critical control equipment. Communication systems operational. Every piece of information helps engineers understand what happened. Deep inside the utility module, another machine begins to awaken. The emergency diesel generator. Unlike the platform's main generators, this unit is designed for one purpose: to provide electricity when everything else has failed. Within moments, its automatic starting sequence begins. Compressed air turns the engine, fuel is injected, the engine cranks. Then, it comes to life. A deep mechanical roar echoes through the platform. For the first time since the blackout, essential electrical power begins returning. Emergency switchboards energize. Critical communication systems remain online. Fire detection systems continue operating. Gas detection remains active. Emergency ventilation is restored. Control room equipment becomes fully operational again. But this is only emergency power. It is never intended to operate the entire offshore installation. Its purpose is to keep the platform safe while engineers investigate the failure. Mechanical engineers inspect the generators. Electrical technicians begin testing the switchboards. Instrumentation specialists review protection relays and electrical fault records. Every department works together. Every minute matters. One incorrect decision could damage expensive equipment or place personnel at unnecessary risk. This is why offshore platforms never restart immediately after a blackout. Every system must be inspected, every circuit verified, every safety device confirmed operational. Only then can power be restored in a carefully controlled sequence, one generator at a time, one switchboard at a time, one section of the platform at a time. Meanwhile, workers across the installation remain at their designated safe locations, waiting patiently for further instructions. They understand that restoring power too quickly could create more problems than it solves. Offshore safety has never been about speed. It has always been about making the right decision at the right time. After nearly an hour of inspections, testing, and careful analysis, engineers identify the source of the blackout. An electrical fault within the main power distribution system had triggered the protection devices exactly as they were designed to do. The system had sacrificed production to protect the platform, to protect the equipment, and, most importantly, to protect every person on board. Once repairs and verification are completed, the first main generator is synchronized back onto the electrical system. Moments later, a second generator joins the electrical network. Gradually, lights return across the installation. Large motors begin turning once again. Compressors restart. Ventilation systems return to normal operation. Control room screens display healthy process readings, one by one. The offshore platform comes back to life. Production can now resume. the blackout is over, but the lessons learned from this incident will remain with every person on board long after the lights have returned. Because offshore, every emergency is an opportunity to improve. Every incident strengthens procedures, every inspection builds confidence, and every successful response reminds the crew why preparation will always be their greatest safety system.
When safety fails on a rig like this, every light goes out.
Thanks for watching. If you enjoyed this documentary, subscribe, turn on the notification bell, and leave your questions in the comments. Stay safe, and I'll see you in the next video.